That's looking awesome. That's really looking great. Hello and welcome everybody to another session of the Raytracer Challenge by James Buck, where I'm implementing a ray tracer based on this book, The Raytracer Challenge, written by James Buck, in Rust, a language I'm learning while actually writing this ray tracer. Before starting with this project, I've never written Rust before, so I'm going along and learning it. And you can follow me, you can take a look at the source code, which links can be found in the description below, to all the resources we are using here. So the last time, or in the last sessions, we implemented a lot of different patterns for our ray tracer, where we can now render gradients here, we can render striped patterns here, we can render checkerboard patterns here, even 3D checkerboard patterns, and we can do a lot of fun stuff with that. So, by the way, this is to WASM, to WebAssembly compiled version of the ray tracer, which you can always reach by just going into your browser to raytracer.xyz. And you will always have mostly the newest version there, which we are developing here while doing this. And even though this is running in the browser, it is running the same code we are writing here in Rust. So you can either execute it directly on your system, or you can execute it in the browser using this website here, if you would like. Of course, this render shell I've created around it, this JavaScript/TypeScript shell, is available in source code as well. So just go to the site and click the GitHub link in the top right corner, and you will be redirected to the repository where you can find the code for this. Okay, so after we have now done a lot of sessions creating all of this pattern stuff, and it was quite fun, I want to go ahead and do something different now, something, the next thing for our ray tracer, so to say. And the next thing to be implemented is reflection. I want to be able to have reflective surfaces. And therefore, I would say we are finished for now with chapter 10, which is our patterns chapter here. Even though we could implement a lot more patterns, or I even indicated that we might implement something like perturbed patterns, where we are kind of fuzzying the pattern creation to create a more organic effect. And I guess we will do this later on once I have the time and the once it's more fun again to do patterns. We have done a lot of patterns, and I don't want to do patterns anymore for some time. So let's go ahead to the next chapter, which starts with reflection and later on refraction. So reflective surfaces, like everything that's a little bit shiny, always kind of reflects things. And then later on, refraction, which will be needed for transparent or partially and semi-transparent objects, like glass, for example. But first of all, we want to take a look at reflection. Let me first quickly commit this change here, which I've just made. Let's do this. Marked chapter 10, which was the patterns chapter, as completed for now. We might revisit this chapter/implementation later on again. Yeah, so let's quickly push this. Okay, so we've pushed this change, and now let's take a look at reflection. How would we implement reflection? So let me, I've prepared already my iPad here to do some drawing, first of all, to show you how this might, or what we are going to do here, how reflection actually works. So let me quickly switch. Okay, so let's think about a very simple scene where we don't actually even have a sphere, but because it's easier to reason about reflection based on planes, for now we simply have a plane here. We might have a light source here somewhere, And now the ray we are casting and sending into the scene, we are tracing it, which we want to render actually, might be, for example, let's see, maybe this one here. So what we usually do is we have this ray and we are calculating the intersection with our objects, which might be here. And then we are doing some more stuff like casting second rays into the light source, for example, to determine how much of the light source can be seen on our object and stuff like that. If we now want to calculate reflection, we actually need some other things, like in our case here, for example, our normal. So we have the normal of this surface here, which we already calculate for other reasons as well, lighting and stuff as well. So what we now can do is we are calculating the reflection based on the normal vector here. So this would be kind of not quite, maybe, yeah, maybe something like this. And this one here then goes from there, and we can calculate this, and it goes back into the scene, a secondary ray, so to say. It goes back into the scene, and we can now calculate if it, for example, let's assume there is some sphere here as well. So if this plane is reflective, we would calculate this ray here, and it would somewhere here intersect with our sphere. And yeah, maybe there is even another sphere here, and this first sphere is reflective as well. Then we can recurse and do maybe this sphere should better be somewhere, I don't know, maybe here to be even hit by the reflection ray. Now we can now have the reflection here, and we can calculate this one and so on. So you see, we are actually doing this in a recursive manner. We are just firing further reflection rays into the scene and looking at further intersections there. And once we found one, we can go ahead and do the same thing recursively again. Obviously, we need to be careful, but we will get back to this later, in order to stop this from going too deep, because first of all, it would get too slow. It would simply be a lot slower than we have it now, because it needs to calculate and fire for each ray we are firing into the scene a multiple of rays again to calculate reflection. And furthermore, if we should have something like, for example, two planes, and we are firing a ray somewhere here in it, it would indefinitely reflect between those planes, and we need, of course, to stop it from doing that at a certain point, because otherwise our rendering would be infinite and would never end. So this is something that we will need to take a look at, but we will do this in a second step. For now, it would be a good idea to go ahead and take a look at this calculation based here, this reflection calculation, so that when we go ahead and render something and we are hitting something that has a certain reflectiveness, and we need to implement this, of course, as a first step, a new material property where we can set how reflective something is, then we need to calculate this reflection ray from the original ray and recurse into the rendering cycle. So actually reflecting, as you can see, something isn't that complex, because it essentially uses all the same stuff and all the same techniques we already have. So I would say let's get going, and let's take a look at how this might work out for us. Okay, let me just put the iPad here to this side, and then we can start. Let me get my keyboard. Okay, so where would we actually start? We would, of course, start with our material, because, as I've said, we now currently have a material structure. Specifically, we have a concrete implementation of the Phong material, which is a special lighting model which we are using. You can, of course, take a look at how we implemented this in a session before. Yeah, and you can see how we have all those different parameters here. Like, for example, we have a color, we have a pattern, which is optional. We have an ambient value, so how much ambient light is there, diffuse light, specular light, shininess, and so on. And what we now actually need is reflectiveness, because now we need reflectiveness, which is a float as well, of course. Maybe we shouldn't call this reflectiveness, but maybe just reflective. We have shininess, yeah, how reflective the material is, I don't know. Let's not get sidetracked by this naming problem here. So we now have a reflective property on the Phong material, as it is the only material we currently have. We only need to add it there. So let's give it a default as well in our default implementation of the Phong material. And by default, I would say it should be 0, because I would like to have it identical to how it's now if it's not set by default. So by default, there is no reflectiveness. Of course, we need to now have this as a new function as well. I'm not even 100% sure I want this. We actually we have all of these builder functions here. Do we still use this anywhere? Maybe this would be a good time to refactor this actually. Let me quickly see if we are still using this function and where we are using it. Actually, it seems to me that we are using it here for a test, I guess. Yeah, Phong material can be constructed with properties. With builder, yeah, I guess we can simply kind of remove this test if we are now removing this feature, because I think we don't need it. And I even have a fix me here which says, okay, maybe we should remove this. And I don't really want to add the reflectiveness here now, because if I do, I will have to touch every position where this is used anyway, so I can then go ahead and refactor this out completely. So let's see. No, I didn't want to go into the Phong struct. I wanted to go here. So yeah, we are obviously using this somewhere in the sphere, I guess, for testing as well. Yes, sphere maybe assign the material. Yeah, but we can easily replace this with Phong default and then with color, and then we are putting the color in there. And the next one would be, what would it be actually? What is the next one we are waiting here? So we have color, ambient, diffuse, specular, shininess. Okay, color, then we have with diffuse, I guess with ambient, then, and then the next one was, oh no, it was ambient, diffuse, specular. Okay, so ambient, diffuse with specular. Then let's see. And maybe here, go to the next line. We will reformat this in a second anyway. And this would be with specular. No, shininess, I guess, is this one. Yeah, and it was 400. I just deleted this. So if I'm now reformatting this, I actually like the syntax a lot better. So yeah, that's quite nice actually. And now we have another usage somewhere which we need to refactor out. Actually, in our world loader, it seems somewhere. Oh, this one, the world loader where we actually create an expected world. Yeah, but we can easily do the same thing here. So we have now a default Phong here with color, which is the color. Then it was with ambient. So we are only using this in tests still, I guess. Then we had with was it diffuse? I guess it was diffuse, but I'm not 100% sure. Let me quickly check. Ambient, diffuse, specular, shininess, yes. So now we have with specular here and with shininess here. And this can go, no, this can't go, no, because we're creating the material there inline. Maybe we shouldn't even do this, but I don't care at the moment. And there is another usage. Where is it? Actually here. So let's do the same thing here. We are creating a default and then using our builder plate pattern. So with color, with ambient, with diffuse, with shininess, no, wait a second, ambient, diffuse, specular, this one is specular. And then we have with shininess, there we go, come on. Yes, let's reformat. And now we should be able to simply remove this new function here and everything should still be good. So I would like to validate this by running our tests. Cargo run, no, cargo test it only is. So let's see. Yeah, seems to be good. So let's quickly at least add this refactoring there. So gap source material, what did we know? This one we don't want. Yes, this one we want. This is the test. Yeah, this one we want as well. Let me get here a little bit bigger so that I can see. Then what do we have here? The material. What did we say? No, we didn't want this. We want the material. So git add source sphere and git add source world loader YAML. And let's commit this. Removed Phong new function. The new function is replaced by using the default trait in combination with the implemented builder. Ah, come on, builder functions on the Phong struct. So we replace this. That's nice. Let's clear this. And let's get back to what we actually wanted to do. So we now have the reflectiveness property in here. So maybe we should quickly add a test that we have a reflectiveness property now, just to make sure it is there. So test fn Phong material has reflectiveness and can be built or has reflectiveness 0 by default. That is something that we should maybe check. So let's see, let M is our material, which is a Phong, and we want a default Phong here, and now we can simply assert fuzzy equality 0.0 with M dot reflectiveness? Reflective. We called it reflective, not reflectiveness. Yeah, there this name is going to haunt me. Okay, so let's see. Let's run the tests and let's... come on. Cargo test. Okay, works. Nice. So this is already okay. This is working. Why did I remove this semicolon there? So what we now need is a way to create a Phong material with this reflectiveness actually. And we don't yet have a builder function for that. So let's add it with reflective. I'm going to call this reflectiveness now. I always want to write reflectiveness and not reflective, so why the heck should I not call it like this, even though if we have shininess, reflectiveness, there we go, should automatically have, yeah, has refactored this, so with reflectiveness. And we are giving it the reflectiveness we want, which is a float, and then we are telling this one the reflectiveness is the given reflectiveness. There we go. And then we are returning self again. So the same build-up pattern as always. So now, after we have implemented this one, we could write a new test, and yeah, we should actually normally write the tests in the other order around. So we should first write the tests and then do this, but yeah, for now, I guess this is fine. Phong material has builder function for reflectiveness. So let's see. Let's have a default material which is called Phong default, and let's call with reflectiveness, and let's just choose a value of 0.42 here. Why not? So the reflectiveness later on will be a value between 0 and 1. So 1 will be full reflectiveness. It will simply reflect 100% of light, while 0 is it will reflect nothing. So it will only have a non-reflective surface. There we go. So now we can actually assert fuzzy. There we go. Fuzzy equality should be 0.42 m.reflectiveness. So now let's run our tests again and let's see. Yeah, looks good. So the next thing that we need to do is we need to calculate the reflection vector, because let me quickly switch back to the iPad. If you remember the drawing, we have here this, I have the iPad on the side there, so don't get irritated while I'm looking to the side here. We have this reflection vector here, which we now need to somehow calculate based on our incoming ray. So we can actually easily do this because we are doing something very similar with our light there anyway. So let's see, somewhere we had this computed, was it computed intersection? Yes, we have this computed intersection, and the computed intersection already calculates certain information, like for example something like the intersection itself, the point where this is, a point slightly above this intersection to make sure that floating point imprecisements don't get in our way, the normal vector, the I vector, and stuff like that. And essentially we already calculate this. So let's see, where are we actually calculating this, because we now want to add a reflection there. And we should actually somewhere calculating the reflection already, I guess in the material then, or where are we? I guess in the shading function of the material. I would assume that there is, do we have a shading? No, a light, color add, how is this called? Lighting. So we should actually have an implementation there for Phong lighting somewhere. And there we should be calculating something like the reflection, exactly, the reflection vector of the light. So because we are actually calculating this to see where the light is going from there and how intense it actually is. So yeah, So we have we implemented a reflect function on our tuples. Okay, that is nice. So let's see. We should easily be able to add to our computed intersection another property, which we would call reflect vector, and it's a tuple, of course. And now we have this one here, which is the reflect vector, and it's a tuple. And yeah, we would just add this one here. And now where are we? I already was at the position where we calculated this. We can get this computed intersection here, and we now need, of course, to calculate the reflect vector. So what we now need is something like, get me this reflection vector, and this reflection vector should actually be the where is it? The incoming vector. Do we have our incoming vector here actually? It's the intersection. So the intersection itself should know the ray of the intersection. There it is. So we have the we need self.ray direction, I guess. This would be the direction vector, and then we want to reflect this direction vector around the normal of our intersection. So we actually have this calculated here, I guess. So we have the reflection, and we should have the normal vector already here. So this should actually calculate our reflection. We are using the incoming ray, the direction of the incoming ray, and calculating its reflection based on the normal vector of the surface we want to reflect it against. And this should actually give us a reflection vector. Yeah, I guess we could maybe write a test to validate this. Do we have, yeah, the pre-computing thingies here are here. So we have one test which is pre-computing the state of an intersection. So let's see, let's maybe do an fn, or is a test, of course. And we want an fn pre-computing reflection vector. Yeah, maybe just that. And now as I'm thinking about the different values we could have here, maybe let's just see if there is a test about this in the book. I would assume. Yeah, there is a reflection vector pre-computation test here. So so let's see. They use a shape which is like, here in our case it's a plane. So let's create body, or let's call it body, because we are calling things body and not shape, which makes a lot more sense in my opinion. So we are just creating a plane. Don't know, maybe a default plane. Maybe we need to change this one. They are just creating a default plane, which is fine with me. Don't we have plane here? We may need to import it. Okay, so now we have our body, and then they're creating a ray. So ray new, I guess. Yeah, the origin point, which is a tuple point, and it is in our case here 0.0.0, 1.0 and -1.0. So they are offsetting it a little bit in Y, so going up a little and going out a little. Yeah, okay, so makes sense. So I guess they will be just firing this thing then down into the down onto the plane. So let's see, tuple vector for the orientation is 0.0. Okay, so now they are going to have minus 2. Is there a 2.0 dot? Do we have? Yes. Okay, so the square root of 2 divided by 2, and the square root of 2 divided by 2. One's minus and one's not. Whereas the problem with this? Can call method square root ambiguous numeric type flawed. You must specify a concrete type for this numeric, like F32. So can I do something like this to give it our type def? No, this will not work, but maybe I can do as f. Yes, this works. Because we have this kind of defined type f, which I wouldn't do again anymore, but we are using it to be able to switch to 32-bit precision if we want to, but it doesn't even make any sense to even want that or do that. So why should we? Press the wrong shortcut there. Let's format stuff. And now we have this new ray. Okay, so let's scroll up a little. We have this new ray, which is kind of pointing down onto the plane. And now, yes, now we are assuming that we have an intersection here. Or we are creating a new intersection. So let's create this one. Intersection will be intersection new. And the intersection is actually at the position 2.0 as f square root. And it will, of course, have the ray in it and the body. So now we have a new intersection there. Yes, and now we should actually be able to get computations, which is what we just implemented, that we can now get this computed data there, and we want to make sure assert fuzzy equals that computations dot reflect v has the following value. Then it should be a tuple which is a vector, and it should be 0.0, and it should be 2.0 as f square root and 2.0 as f square root, and that doesn't make any sense. I guess there should be a division by 2 there, because otherwise this wouldn't make sense at all. So let's see. If we implemented reflection correctly, we should now get this running. And we are failing, of course, but we are failing with asserting fuzzy equality tuple, not a number, not a number, not a number. Okay, we did something very wrong there. And what is irritating mostly to me is that I think that actually this one here is all not a number, so it wasn't correctly computed, I guess. So let's see, what the heck did we do wrong there? So the direction, and we are reflecting it around the normal vector. This should definitely not be not a number everywhere. Let's quickly print print this one out here just to, or as I've recently learned how to actually debug stuff here, which is quite easy. Let's just run this one test here. No, where is it? Reflection there, and let's start it in the debugger and let's see what's actually in this variable. So maybe we can take a look at this. So yeah, I guess something is very wrong here, because as far as I can see, the reflect value as it's calculated, it's okay, it's not a number, but what is strange here is that actually the I vector has a not a number in there as well, and our over point has a not a number there in there as well. So I would actually assume that we made some really weird mistake within our test itself. So let's see. No, not there, in the test. I would assume that we did something wrong here in our test. So let's see. Oh, we created a square root of -2. Yeah, so essentially we would have some sort of complex number there in the end or something. This is not processable by a float, of course. So I guess this is already where we were wrong. Let's see, because oh no, it's something that was executed for the testing purposes here for debugging. Yeah, okay, so of course you can't create a square root of -2, at least not in the realm of this sort of numbers we are using here. So that's completely, yeah. Okay, let's reformat the file and let's commit this, because we have just done the next step in what we needed to do. So what do we have here in material still? Did we add it? Oh, we should maybe add this first. So we didn't commit this. Yeah, so let's commit this one first. Allow material, especially Phong material, to have a reflectiveness. This value will later be used in computations which are to be implemented to realize reflecting objects in our scenes. There we go. And now we have, what did we actually have here? Source intersections. What did we change there? Yeah, we actually calculated those. Yes. Yes, we had this test there, okay. And gap source computed intersection. We needed to add this information there, of course. So edit reflection vector of incoming ray direction to computed values. Within our intersection, we now calculate the reflection of the ray direction vector based on the surface normal. This will be used to recursively render reflection color in a further implementation step. Yeah, so we already have this now. So now we have this reflection vector. There we go, reflection vector. So now as we have this vector here, this reflection vector, we actually need to do something with it, to calculate something with it, because if there, for example, would be some sphere here, we would of course need to now have an intersection with it. So let me try to even though this is completely off the drawing axis here at my hand, let me try and do a little bit better sphere here. So there we go, maybe, yeah, a little bit, I don't know. If we now hitting this one, we of course need to calculate the corresponding color there. So yeah, I guess we should do this and go ahead and get the next step going. So in order to calculate our reflected color at all, I guess we will do this. Where would we do this? where do we have our color at the moment? Is it in color at? No, come on, where do we world color at? So yeah, I guess we have a world color at, and we need to be able to ask the world this. Yeah, it actually makes sense. We currently can ask a world if it is shadowed somewhere, and we can have it calculate color at for a certain ray. So I guess we need to have a new function here somewhere, maybe in between, I would guess. Let me scroll this up a little, which would be, and I'm not 100% sure that this is this a public function or is it? I'm not sure yet. Let's see, because we need to call this and color at somewhat recursively. So, but the question is, who is going to initiate a call to this function, which we could call reflected color at, I guess. And it would take array, which is array. And of course it would have access to self here, and it would return a color. So this one would actually calculate the reflected color. The question is there if this actually even makes sense. Isn't it that we are only using the property of the material there, and I guess I've just made a kind of a little bit of an error because I need to be able to retrieve the reflectiveness of. I guess what I need to do is, I guess that I need to implement or create a trait for reflective materials. I guess that would make sense. So let's create a pub trait reflective. And this one would have a function called reflectiveness, and this one returns a float. It gets, of course, self in there. Yes, I guess that would be okay. And now the Phong material can actually implement reflectiveness. Where are we? So, of course, we are implementing this for material as well. So, reflective for material. It's kind of the same thing. It's reflectiveness, and it's getting self. Come on. Getting self, there we are, and we can use the match here. There is a curly brace too much, and now if it's a Phong, we are just passing the reflectiveness call through. There we go. Now it is, of course, telling us that Phong doesn't implement reflectiveness. We will do this in a second. We will do this just here. So impl reflective for Phong. Implement missing members, of course. So we are just returning self reflectiveness, nothing more. And there is a G missing. And now this should work, but now we should be able to ask every material for its reflectiveness. And this is important because even though we only have one material there, we need to be able to do that. Okay, so let's see. Let's first of all concentrate on calculating the reflected color. So only the color that that is there for reflection for a specific ray, and yeah, and I guess an intersection, because reflections always only can happen at an intersection point. So at this moment we already have one intersection. So let's see if we can have the intersection there, I guess. So maybe the original hit there. Let's see. So we want an intersection there. Isn't this called intersection? A struct with a similar name exists. Intersections. No, I want one. Yeah, there. Create Interesting. Okay, so the first thing that we are going to do is we are taking a look at the hit. And the hit should actually have a body, I guess? Yes, it does. And the body should have a material. Yes, nice one. So, and the material now can be asked for its reflectiveness. Yes. And if this reflectiveness is equal to 0, then we have a hit a non-reflective material. So if we hit a non-reflective material, we don't need to do further calculations. We could, of course, still do them and then multiply the new reflective color in there by 0, which doesn't make any sense. So we can optimize here. If we have a hit a non-reflective material, we hit a non-reflective object or body, let's call it body. Then we are simply returning color black here. So if we have a hit to a non-reflective material, we have no reflective color. There is nothing reflected. So we are returning black. On the other hand, if we have hit something reflective, we of course need to calculate this one. So what we then do is we go ahead and make let reflected color, and we are just calling self. So on the world we are telling it that we want the color at our, let's see, we want the color for our reflection vector. So we need to create a new ray. But why I'm just stopping there is I'm thinking that we now would be going ahead and taking and creating this pre-computed value that we are already computing here as well. So I'm not 100% sure that I don't want to change this and give this not a hit, but I want to give this a material, which is, I guess, a reference to a material then, and I want to give it computed intersection, which is a reference to a computed intersection, I guess, because I don't want to recompute this. So let's just provide it with the specific stuff here. So we can do a material reflectiveness there. And now we can, let's create, let's call this reflected ray. Ooh, what did I do there? Reflected ray. And now we can create a reflected ray by getting a new ray. And the origin point actually would be computed intersection dot our over point, just to be sure that we are not going ahead and due to the fact of floating point in precisement, we are just lying below the surface, the same thing that we did for shadowing and stuff, you might remember. So we are taking the over point, so the hit point, but a little bit over in direction of the normal vector there, and then we can take the computed intersection from our reflection vector here as the direction, which should now be correct. And actually now we are calling the color calculation again to do the same stuff again and calculate our color for the reflection. And now we have that. And of course we need to take care of this infinite recursion thingy there, which you can now see, because self color add is here, is this function, and this function will later on call reflected color add, of course, to incorporate the reflection color there. And you could see how this could be an endless recursion, and at some point the stack will just blow up. So now that we actually have the reflected color, the only thing that we still need to do is we need to return it. But we don't return it as we have calculated it, because this would be 100% reflection. And we might have another reflective index there. So we are just returning the reflected color multiplied with the material's reflectiveness. So we are getting this value there again. And we are returning this. So we are multiplying this one with the reflectiveness. So if the material only has 50%, like 0.5 reflectiveness, we are just returning 0.5 of the color. So we are just multiplying every component of the color with it. And so, yeah, what has happened here? We didn't use ray. Yeah, this is kind of right, because we didn't compute the... Yeah, we don't even actually need the original ray there, do we? Because we already have everything we need incorporated in our computed intersection there. So yeah, I guess this one can go. Quite right of the compiler to tell us that this might not be needed there. So yeah, so now the next thing we need to do is we need to incorporate the calculation of reflection into our color add function. But I'm wondering if we want to somewhat write a test for this before incorporating this. But now there is this part with where this, let's delete this breakpoints here again, where this recursion thingy actually kicks in, because now of course what we need to do is we need to somehow incorporate that reflected color somewhere in our color calculation. So if something, the first ray is fired and the color is calculated, we want to incorporate reflection there. So what we need to do actually is we need to put in reflection information. So we need to, yeah, to actually calculate this as well. So let's calculate call this surface color maybe. Let's calculate the surface color here now, and instead of then just returning, we need to calculate the reflected color there as well. So let's do self reflected color add, and we can just put in the material and a reference to the computed intersection there. And now what we are returning actually here is we are using our surface color and we are adding the reflected color, and then we actually have reflection. But now we have the problem that I've talked about in the beginning. We have the problem that if reflected color add, if color add here is calling reflected color add, and reflected color add is calling where is it? Color add. At least in cases where we are hitting a reflective material. We could have this, where is my iPad? We could have this problem that I talked about, where we have endless reflections. So if we, for example, have two planes, we could have reflections between them, and it would never stop. Or in our example, which we have done just the tests for, we have a sphere here, and we are firing something like this there, and then it is reflected to this side, and then it would be reflected to this side again, and to this side again, and to this. It would just go back and forth infinitely. So if I now implement it like this, I would assume, let's quickly check if this is the case, but I would assume that now if I run the tests, it actually will fail horribly, and it will give me a blown stack. So yes, Stack Overflow, because it now goes back and forth and back and forth and back and forth and back and forth and back and forth, and it's doing this recursively, and so it's an endless call. It's going on and on and on and on and never stopping. Therefore, we need to make sure that we can somehow specify how much of those reflections of a reflection of a reflection of a reflection we actually want to incorporate in our calculation. This is not only important to have a still quite fast rendering, but it is important as well to make sure that nothing breaks because it can't be rendered anymore. Yes, so let me quickly think where we would incorporate this best. So what we actually would need to do is we would have this function here, reflected color add, which could get another parameter. For example, let's call it remaining reflections, and this would be, I guess, U8, maybe even let's give it U size. It's not really important because the number will not be big. And what we will do here is we will now say if the material reflectiveness is not there, so if there is nothing reflective in the hit, then we can return black, or if remaining reflections equals 0, we will just stop there as well. Okay, so now we need to, of course, provide those remaining reflections here as well, and we need to actually pass them, because every time we are now going one level deeper, we should actually decrement this value and pass it along. So our color add function would need this as well. But I don't like the fact that we just incorporate this into our public API. I would like to have this configured somewhere in the world, maybe, but I would like it to be, for now, to be a default value, which we might be able to override later on, but I would like to have it something like maybe just we are doing could be doing something like, let me quickly think, something like reflection limit or something like this, and let's maybe do something like, yeah, this will be a U size, of course, and for now we could just put this in here and say we have reflection limit of, I don't know, 5 maybe. And this is hard-coded for now. I will put a fix me there, fix me, make reflection limit configurable, and I want another fix me there, because the world should have the builder pattern as well. Switch to builder pattern. We can do this sometime later on. Okay, so now we have this reflection limit property here, and we could start our first reflected color at call here with this information. But the problem is, I would like to take this value from here, but Rust, as far as I know, does not support default arguments. So I can't do something like remaining reflections, remaining reflections usize self dot blobs or even 5. I couldn't do this here because Rust does not allow this. So I would assume, because I don't want to have this in the public API, the API we are calling in our ray tracer, I don't want to have this reflection limit configured there, but within our world, I would say we need another color add function. So we would need some event color add with reflection limit, and this will be otherwise it will be identical. It will take array, and it will, or it might even only take a reference to array. We don't even need to copy it actually, but yeah, we are copying it at every other place, so why not? And it will take remaining reflection. How did I call it here? Remaining reflections. Yeah, okay. So, and this is a usize. It will take this one. And now what we actually can do is we can take everything that currently is in here and put it in here. And now we can have this reflected color remaining reflections. We can just pass it through. Oh, I should have not written %self, but %self, then the compiler wouldn't be screaming at me. So let's see. Yes, I need, of course, to return a color as well. So this should work. Okay, now our color add function should simply go ahead and call self dot color add with reflection limit. It passes the ray through, and it takes self reflection limit as initial parameter. And now actually this should already do what I want it to, more or less, because now we have this, it get me the reflected color, remaining reflections. And now this one, once it calls color add again, it doesn't call color add, but color add with reflection limit, of course. And it puts in there remaining reflections, but with one. Wait a second, doesn't. Something like this. Now there should be a maximum of calls these reflections can bounce forth, and yes. Oh, so default is actually, yeah, maybe I should use my new function then here, or even reflection limit 5. Maybe I should have implemented world in another way when I have, or this new function in another way when I actually have a default implementation for world, which I didn't even know. So yeah. And now this is, yeah, now I need, of course, to adapt the tests here and need to put in here something like, in our case, I guess 1. And here as well. And now those tests should run again. Yes. And we have actually limited our reflection depth. What I could do actually here is now, if I put a 2 in here, actually the color should change, because we are now incorporating 2 lines. So actually, yes, we assumed that we would have 1.25 and so on, but now we need to add half of that on top of those values again, because it's going back and forth, and this makes absolute sense. So yeah, even though we might need or should create another test now, which is testing all those back and forth rendering and stuff, I would very much like to quickly adapt the YAML parser to allow for specifying a reflectiveness of a material and then render something with it, because we are at a point where we can do this. So let's quickly take a look at our YAML world loader here, and yeah, let's see. We are going to somewhere we should have a parsing for Phong material. There's material type Phong. And then we seem to parsing out all those nice and good information there. And I guess we could just copy this one here. And this will be a very quick addition, I guess. Come on, what did I... We are just adding... we are just adding reflectiveness here. And then we are taking the reflectiveness value and putting it, material reflectiveness. And then we are just putting this one. Come on, reflectiveness. And we are just putting this into the material before we are putting it back into the world. And I would assume this already is enough for us to render a reflective surface. So let's see, worlds. What do we do here? We have 3 spheres and a floor. Well, what is the last thing that I actually created? An Amiga boing ball thingy. You can find it in YouTube, on YouTube, where I tried to simulate something like the Amiga boing ball logo just for fun. Once we got those checkerboard patterns, I have a short about that on YouTube, where you can see the animation. It's quite nice. But let's quickly run this because I want to just introduce, or first of all let's compile, then let's go ahead and render this again. And yeah, it's a lot faster. So I worried I might have made something go kaput there. So yeah, this is what I rendered there, something like the Amiga boing ball, and I liked it quite nice. But how would it be if this is now reflective? That would be quite awesome. If the wall behind the ball would be reflective, and the other floor there as well. So let's give this material a reflectiveness. I would love this. Reflectiveness. Let's see, 1.5 maybe. And let's give the wall a reflectiveness as well of 1.5. And let's re-render this. Yeah, and it takes a little bit longer. And let's see. Okay, this is this is awesome. As you can now see, both of the walls are reflecting, reflective a little bit, which is kind of creating a weird effect here, because it's not only reflecting the ball, but it's of course reflecting the other wall as well, which is, yeah. But as you can see, this gives the whole scene something completely it suddenly looks a lot more realistic. So maybe we can ease something here for our eyes, indeed, by just doing some change of the pattern here, by just having this one for now commented out and doing just using the colors as separate colors maybe, and this could actually look quite nice. Let's maybe see. No, this is the wrong one. This is the one I wanted to change. So because then things would look more even and not so strangely interweaved. Let's take a look. Maybe this looks nice. Okay, this definitely doesn't look at all as I would have expected, but I guess, yeah, it's right. This is maybe the background wall shouldn't be reflective. Let's see what happens if the background one, if this one, the floor is reflective, but the background wall is not. Yeah, this kind of looks nicer to me, but maybe I don't know, maybe the reflective one could simply be something like a very, let's see, color 0.1, 0.1, 0.1, and it could be it could have quite it could be quite specular, and it could be shininess. It could be quite shiny, maybe. Maybe this would look nice. Let's see. Maybe it's too reflective. Let's make it less reflective. Yeah, I'm not sure if this is kind of irritating now, because it's just directly from in front. So let's maybe play around with another one of our things here. Let's have this the last one we did here, this one with the checkerboard patterns and stuff. So maybe let's take this one, and let's maybe make the floor here reflective, just the floor. So reflectiveness, yeah, let's do 0.5, and let's try and render this one. Come on. So yeah, I guess this is rendering 4K. Yes, so as it is rendering 4K, it takes a little bit longer. But I'm still quite like the quick rendering here. It's still quite fast. So yeah, this is already looking really nice, because now the spheres are reflected in this floor, and this looks kind of amazing. Maybe we could do with a central sphere. So let's see, a middle sphere which doesn't have a pattern anymore. Let's remove this pattern here. Let's give it a color of, what would be a silverish color? Silver color, what would be? Yeah, something like, I don't know. Yeah, of course, it would only be gray, but I'm thinking about what kind of gray. Yeah, maybe maybe a very bright gray. Let's just see what's happening there. If we just do something like 0.9, 0.9, 0.9, of course it has a very low diffusion factor. It's very specular, maybe even more than just a little bit, and it has a shininess of, it's very shiny. And then we make it reflectiveness, and we give it a reflectiveness of 1. Now let's see what happens there if our main sphere is 100% reflective. That should look, I hope it will look amazing. We will see. It should be kind of a mirror surface. So let's see. Let's see what happens there. Oh, this is awesome. This is really awesome. And there you can even see this reflection of a reflection of a reflection thing going on between the let's say here the floor and the sphere. But this looks just it's just awesome. So let's see, maybe if we even, I'm not 100% sure, if we give this an even white, if we just make it white, maybe it will look even better. I've no idea. We need to play around with this because I don't actually know. Okay, it's mostly looking the same. I'm a little bit, or I'm not 100% sure why this is. Wait, we are actually, what if this doesn't have its own color? Then it should be looking like a mirror, because now it has an own color. It has a tint of white, so it makes everything brighter when hit, because the colors are actually added. Let's see. Yes, this is a mirror. That's looking awesome. That's really looking great. Oh yes, this is really great, and you can even see there then the perspective distortion there, because we are calculating reflections correctly from where we are hit, and then checking and bouncing back the rays there. And this is actually why ray tracing is so much fun, because once you have created all the basic stuff, you can actually create something like this quite easily. So if you are thinking about what we now did effectively to create reflection, it wasn't that hard, and it looks absolutely stunning. So what I would like to test is if this somehow changes. I don't think it will, but if it visually really changes, if we are setting the bouncing level, the maximum recursion depth, higher, but I don't think it will change much actually. But let's see, we could do this here now, and I guess I will make this configurable by the world loader and stuff at some point, but for now let's just make it a lot deeper by, for example, setting it to 32. And now let's first copy the main camera to something like main camera recursion 5, and then let's run the rendering again, and it will take a lot longer now. Oh, I would have assumed that it would take a lot longer now, but it was quite okay. You can actually see it slow down in the middle a little bit, because it's hitting all the reflective surfaces there. So now let's see, is there something really different between this one and, let's see, we can somewhat switch between them. There we are. So we have, this is way too big. So we have now this one here and this one. That's interesting. Why is the, oh, okay, of course, the, as the, yeah, of course, as the, as it is going into infinity there, no, It's kind of a little bit changing, but as with this reflection, you can see it's mostly the same. It's more or less the same. So it doesn't even make much of a difference there. Yeah, so I guess it's completely fine for us to just have the 5 there. Oh, this. Wait. This looks, it's the second camera angle, and this looks really nice as well, because it is from a lot more down below. That's really nice as well. I like that. But the other one is even greater, I guess. So yeah, so we should change this back to 5 here, I guess, and then I would say we could have this one with we are just removing the commented out stuff here. We didn't change a lot there. No. Okay, so now we could copy this one, and we should actually, where is the, there it is. Let's rename this one and call it 3 spheres reflective. And just for the fun of it, maybe let's we are going to play with it a little bit more, but for now let's get and commit this stuff. So now we have everything quite fine here. So let's maybe go ahead and clean this up a little and then play with the reflective spheres a little bit more, because I would very much like to see what it looks like if all of those spheres are actually reflective, even those which have a pattern, because there's no reason why a pattern sphere shouldn't be reflective. And what is if the reflectiveness of all of those is 1? I just want to see what this would look like actually. So maybe we can see this. Let's see. Rendering, compiling, rendering, and let's see how this looks. Oh yes, I always forget that there is a second camera angle there. So open main camera. It looks I don't know, it kind of looks a little spooky. I'm not sure. Yeah, but now everything is reflective. Of course, this is something that in the real world is quite strange. Because what is even more strange, and this is what actually is what you are actually seeing there, is that even though those spheres are unbelievably reflective, they are not very shiny on their surface, and this doesn't make sense. This looks a lot more realistic because it has a very narrow focal point. It's a very shiny surface defined here, and those surfaces are not defined shiny. They are very diffuse. And so they are unbelievably reflective, but very diffuse. And this doesn't even make sense, but it kind of looks interesting. So we could, of course, change those parameters and make them more shiny. And then this would most likely look a little bit better. But the second thing that is making things a little bit strange here is that there is nothing above this scene, and now as they are reflecting all of those information which you usually can see above this line, you can actually see, and this is what makes this sphere strange, that there is nothing above. So we would need a ceiling now, or something that is on top of this, for it to look more realistic again. Yeah. But this is kind of marvelous that it looks like this. I like it. Yeah. So let's maybe one last thing we could do. We have this middle sphere here, and I just want to take a look at where it is positioned. It's positioned at -1 and -0.5, then it's 1 above and it's 0.5 in. So what I want to actually do is I want to position this second camera to, wait a second, middle sphere. Let's see, if we move the second camera to -0.5 on the X, and then it is, yeah, that is okay, maybe only 0.5, and then we are going a lot closer there. Like, how big is our middle sphere? Middle sphere is, it's a 1 sphere, so maybe we are just going there by 1.5 or maybe 2. This could already look nice. I want to get very close to this very reflective sphere, and let's remove the reflectiveness of the right and the left sphere again, because this kind of looks a little bit silly. And now let's render this again. Let's see, because I'm assuming this could look very nice to see the scene, but actually by looking at it through the reflective sphere in the middle, let's see. Maybe this is nice, maybe this is a completely waste of time. Okay, this looks quite awesome. I just need to kind of center it more, maybe. Maybe we need a little bit more back off from here, and we are still not at the right position. I guess the sphere was at 1, yeah, and we are off by, but I want to be off a little bit, so let's maybe move this to 0.8, and let's take a look at this again. It could look very nice. Let's see. Yes, this looks really nice with just a hint of this one there. Yeah, that is that is really nice. That is what I call a reflection. Yeah, so thanks for joining me again for this actually quite long session then in the end, I guess. But I guess it was worth it, because I really like what we have now. We have now reflection. And yeah, I guess in the next session we will maybe clean it up a little, maybe create some more tests. I don't know, maybe I will do this in the meantime, we will see. And then the next big topic we will cover is refraction. So making things not reflective, but making things transparent. So something like glass, for example. Of course, we can combine those rendering techniques to create something like glass, which is, of course, something you can see through, but at the same time, it's reflecting light. So yeah, I hope to see you again in the next session and installment of this. I will, of course, roll this out hopefully in the next days then to the raytracer.xyz, so that you can actually use the reflectiveness property here in our raytracer shell, which you can just open up in the browser and work with it. Yeah, I will hopefully incorporate this. But one thing which is definitely apparent if you're looking at this, how much more realistic this scene alone looks like, because there is now some sort of reflection in it in comparison to this one. It's so much more organic and lifelike. Yeah, this is just very amazing. So yeah, thank you again for joining me, and I hope to see you in the next one. Bye.